So, folks, to just give a little bit more of a background, I belong to illumifin, and Sriram belongs to Target, and we're kind of working in the data area space for a longer period of time. When an opportunity is given to our organization, a challenge is given to our IT organization here about how do we actually, build the model once and use for multiple purposes, whether it is actually for reporting feeds or for analytical purposes or for AI purposes. I want to build once and then use it everywhere. How is that possible? I mean, what kind of modeling technique we need to be using? And that's where I got passionate about the data vault concepts. And fundamentally, what actually really made me interested in this one is the separation of concerns. It is actually one of my core architecture principles, whether I do it, whether it is for applications or data. It's all about separation of concerns. The more you separate and then create a components, the more agility you are creating into your architectures. Now, that's my core principle. In the case of data vault, it is clearly separating out the keys, which are the identifiers of the nouns and the relationships, from the payload, which can keep changing. Take a simple example of an address. Today you may be having just address one, address two, city, state, zip. Maybe tomorrow you want to add a third line of address, right? So, the data, which is actually representing the behavior, keeps changing in the real world more frequently than really the relationships between the entities. And that is what data vault is clearly separating out into the form of hubs and links and satellites, right? So that concept really, caught my eye, and I started looking into, oh, that's very nice. So let me actually start understanding this and then see how I can actually do the automation. And as part of my journey, after understanding some of the concepts, and of course, I went through the some of the recommended trainings, etc., on the automated DB as well as the data vault concepts, and then the real problem comes in. I have limited funds, and none of my databases are actually really on the data vault concepts. So how do I actually convert my existing laundry list of databases into a data vault in a cost-effective way? The obvious answer is automation. So we need to start understanding how do I actually make the automation happen in a cost-effective way. The automation is all about, again, it's a patterns. Identify the pattern, repeat the pattern. It's that simple. So now, as part of this journey, we're going to talk a little bit more about some of the patterns that we identified and how we actually took our journey from the existing relational databases to this. Okay, so now let me actually go to the, here's the layout of the today's presentation. We'll be briefly talking about introduction, some of the patterns we observed, the data movement, and how did we actually go about actually, automating from end to end. So to start with, there are actually some constraints. These constraints are based on my real life. In my current organization, 90 to 95% of the data is on relational databases, which is, already has some kind of a structure associated with that. So then my goal here is to actually just focus on that and then do the automated conversion of that into the data vault for my purposes, rather than boiling the entire version, right? So that's why I call this as opportunistic automation. We, as we understand the patterns, we keep automating them. We keep finding new patterns. We keep automating them wherever it is possible. Our goal is to not say that, okay, it has to be 100% automated. It's always about, balancing the act of what it means to automate, how long I'm going to take, versus is this actually only a one-off situation where it's not worth to automate, right? So some of those conversations do happen. We take some exceptions. over a period of time, we find out, oh, this is not actually one time. There are multiple scenarios where this is possible. Okay, we'll automate that, right? So that kind of a balancing act is used to actually deliver the project in time for our organization. So coming back to the relational databases, the relational databases are based on set theory, and the data vault is also based on set theory. And the data vault, of course, if you take it in a holistic picture, it is much more than just modeling. It's just more than some of the principles. It has its own additional processes, policies, procedures. It's actually much broader than that. But for our purposes, I focus on one thing. I understand that the data vault is actually clearly separating the keys and the model, the payload. So the payload can keep coming from one or more systems. I can actually organize the relationships separately so that whenever I can actually, majority of the joins I can automate, I can actually have a clear meaning of the nouns and the relationships of the objects that I am using at my organization. So that is my focus area, and then that is what is automated. So in the case of relational, it's, I kind of oversimplified, you know that these are kind of, you have primary key relationships like a foreign key, and you establish some of these by using the metadata of the relational databases. In the case of SQL Server, it's called information schema, right? So, we actually, significantly leverage those concepts that are already available in the relational databases. And then in the vault, as we, I briefly introduced earlier, it's all about separation of keys, the nouns, which are the hubs, links, which are the relationships between the nouns, and the payload that is associated with either the noun or the relationship, right? So if I just understand that and stay focused on that, we could automate almost 85% of what we wanted in the form of a vault and achieve the results that we wanted to achieve. So with that background, so now let me actually get into the details of it. So I'm relying primarily on these concepts of, okay, I understand some of the patterns of relational, I understand some of the patterns of the vault. So the goal is to actually, migrate from one to the other, and what kind of process we created. So step number one is a vault model. And then we actually generate the scripts and then automate the portion of actually how we are generating and pushing the data to in the form of creating the data vault tables, along with actually pushing the data using the automate DB. Fortunately, we have a lot of these open source tools that actually did great job of understanding some of our needs and simplifying our approach, or simplifying our life by providing predefined macros that we can use to produce what we wanted. So I am actually a fan of design first. So that's why on the vault, the model creation alone is not automated, even though we actually specify some of the patterns associated with it. So the patterns in the model are: a source table is mapped to either a hub, which is a noun, or to one or more link tables. Usually, almost 99% of the time, what we saw is that if you take a source table, which is a relational table, given that it is in the third normal form, it is either mapped to a hub or to a link, followed by associated, the payload tables, right? If it is actually a link table, then usually if you have actually an identifying relationship, then usually that source table is actually mapped to a link table. The non-key columns we're kind of putting into the satellite. If a source is mapped to a link table based on a foreign key that is part of the primary key, its non-key columns mapped to the corresponding link satellites. These are very simple principles we applied. But yes, can this be automated? Sure. If you have actually a good modeling tool, you can actually auto-generate some of these models too. But we wanted actually purposeful modeling, given that we have a lot of spaghetti right now. And one of the intentions behind this particular project is to really cleanly define the appropriate nouns and the relationships so that I can auto-generate some of the joins. I can actually, say that given that I have a good, meaningful data model, I can actually rely on that for all the other purposes instead of dealing with the nuances. And once I have the model, then I need to start actually putting a little bit of an intelligence to that, which are kind of exceptions. If I need to actually auto-generate some of the exceptions do arise, such as, oh, I have a primary key on the source table, but I need to be slightly altering that. I have actually a foreign key that has a different name on the target side of it compared to the source. Yes, the ideal data vault says that, hey, you cannot change the keys, right? And you need to be able to preserve the source modeling. You need to be able to translate from the vault back to the source. Most of the cases it is true, but we have some nuances. Some of the nuances on the source side are we have history in the main tables. We don't want to carry the history because the history is part of the satellites that you're already creating. Why do you want to actually push that again? So some of those minor adjustments are made to make it a little more practical. I'll just briefly go over this. So this is the last slide before we actually go into some of the specifics. So Sriram, do you want to explain this, how we mapped actually a source table to the target?
Sure. So like Srini mentioned, we followed a design first principle where the first objective is always to first lay out the data vault model based off of the relational database that we had stored on-prem. So in this example, we have a small snippet of the overall model where we have three tables: the product description, the product model, and product model product description. So those three are the relational data tables that are in the relational database. And so from that, we kind of need to construct the data vault model. So to do that, we first mapped in the blue tables represent the links, where that product model product description gets mapped to a link table, a link satellite, and then a small hub, which is the H culture. The red table that gets mapped to a hub and a hub satellite, because that's a noun that represents the description of a single product. And the actual product model, which is green, gets mapped again to a hub and a satellite. So you can see that those two are connected by that product model product description, where product model product description is inherently kind of a link between H product description and H product model. So it easily gets mapped to just a link table in that data vault.
Thank you, Sriram. So with the same kind of concepts are followed, and for our purposes, we have actually inside our organization a licensed product called Power Designer, and we use the data to do the actual modeling. In this particular case, for demo purposes, I'm actually sharing the Microsoft SQL Server sample database AdventureWorks. In our case, we have actually an application that manages policies, which is around 2,000 tables, and we could actually, apply the same concepts there, and then we could successfully deliver the entire project in less than 3 months. But for our purposes, I'll actually demonstrate the same principles about how we followed on a sample database. I know this is an eye chart. The intention here is to just briefly show the same concept, but at a little bit a broader scale. These are the smaller set of tables that we selected from the AdventureWorks. These are the relational tables, and you auto-generate this from the SQL database. You can do that, or you can actually create the model by yourself. And once you have this one, by using the principles that I briefly talked about, what we're doing is we're kind of converting them into hubs, links, and satellites. Okay, so this is actually created upfront as step number 1. And then I just did mention about some of the annotations. The annotations are specified right here as a comment saying that in this particular case, the source is, this is the source table from which this is mapped. Okay, then you have actually, for example, a link in this particular in some cases, you have a foreign key exception. You're just mentioning that. There are few scenarios like this where you need to specify, give some hints, so it's easy for me to automate. Barring that, it is a simple standard model, nothing else abnormal about this one. So once I have the model that actually shows the relational and then the actual target model, I can auto-generate the database model. I can select all the tables that I'm initially interested in and then click on OK. It actually generates a SQL script. And that SQL script, looks something like this. And what I do is simply run that one into a database that actually creates some of those hubs, links, and satellite tables. Okay, so this is actually creating a SQL database that has the hubs, links, and satellites that we, that are just modeled. And now I have this information. I also have the original data model, AdventureWorks, okay, with all the tables and relationships and metadata. Then the next goal is to take the information of the source, take the information of the generated tables, and the intelligence that is actually created in the form of annotations, and create intelligence that is needed to auto-generate the automate DB scripts. So step number one is to prepare what is needed, and that's where all of this M underscore. So it is producing some of the scripts. Sorry, I think I showed you. I don't know whether you guys then saw the Power Designer tool where I saw the model. I showed the model. Okay, let me briefly show you that. So I was just mentioning about this one. This is the real model. It is auto-generated. And then here are the hubs, links, and satellites that are modeled. And all we did is we just mentioned about the annotation right here as a comment. Okay, so only the exceptions are actually documented. Every table will have a source along with the foreign keys exceptions or primary key exceptions that we just briefly talked about. And then we auto-generate the script, the SQL script. Let me now flip to the SQL Management Studio. The auto-generated scripts look like this, and then when you run, it automatically creates some of the vault tables. Now, given that we have the source, which is actually the AdventureWorks, the real database, which is kind of mimicking your application database, and then I have the corresponding vault tables. My goal is to actually leverage that information from those two places and auto-generate all the needed intelligence for automate DB to produce the vault. Okay, and let me just a little bit fast forward and then come back to this one so you understand a little more on the concept side of it.
You were showing Power Designer, right? So the data vault model, was it handcrafted or was it auto-generated from the relational model?
The model alone is actually handcrafted. It is on purpose. This is an opportunity for us to relook into what we have in the models on the source side of it, and then have a better understanding about the nouns and the relationships. And as I said, given that the importance of this one is not just actually copying the data, but also use it for multiple purposes, we want to carefully look at the model and ensure that we have the quality model in place. Though it is possible that some of the concepts that I mentioned about how we are mapping hubs, links, and satellites through the nouns, etc., a good portion of that can be automated by using same tools like Power Designer. You can use some of the macros to create, but we purposefully did not do.
Yeah.
You guys can see my Visual Studio, correct?
Yep.
Okay, so when it comes to actually the wall side of it, the concepts are any of these macros that we are talking about.
Srini, can you move the file folder, please?
Move what? You're seeing this screen?
Yep.
Oh, okay. So the concepts of the macros, carrier name, SOR type, and all this information that is needed by the Automate DB is the intelligence that we are talking about. How do we actually produce all these column names and the way that is actually needed here in a way that it is easy for me to auto-generate. So we made that into two-step process. Step one, use the SQL Management Studio and SQL Information Schema concepts to produce some of the relationships. Step number two, leverage Python to auto-generate all of these scripts, whether you have one table or 500 tables or 1,000 tables, right? So it doesn't matter. So as long as there is a concept, then we auto-generate this based on the intelligence that is created. So those are the two steps that we followed. And then you're just going to run that into Snowflake is what actually our target database is. So now let me quickly go back to, now you should be seeing my SQL Management Studio.
Yep.
Okay. So they use the generated script from the model. We ran it, and then this is the one, and then we simply run this. These are the multiple stored procedures that actually produce the relationships, and at the end, you'll see that there is a clear lineage that is being produced that shows, okay, here is my source table and the corresponding primary keys, foreign keys, constraints that are associated with it, what are the, where is that coming from? These are all the simple relationships between the components that we actually are needed in the Automate DB, produced by writing some scripts leveraging the information schema concepts. There are a few stored procedures that are created based on this. Now, once I have this, then we will be actually running the Python script that actually takes all this information that is available here and then produces the Automate DB scripts. So Sriram, I'll actually now share the Visual Studio, and you can just walk through the Python.
So
I'm not sharing the details, guys. Certainly if we have time, I can go into some of those stored procedures and some of the tables and then share some of those as well.
So as Srini pointed out, the overall process flow starts with creating the model, generating those scripts so we get the actual tables in the SQL Management Studio. After that, we're running some stored procedures to kind of gain the intelligence of what tables are actually going to get mapped from the relational to the data vault. So based off those intelligence, we have tables like, in this, for example, in the staging layer, what tables in the relational set get mapped to what tables in the actual data vault model. So based off of that intelligence, we were able to generate or create some Python scripts to actually auto-generate some of those Automate DB scripts. So right now, this is just the main.py. So all we do is just run that Python main.py. And Srini, if you want to just run that command real quick. So essentially what we're doing here is we start off by creating the hubs. So Srini, can you go into, once the files get generated, they get generated into a models folder. We can go into, for example, we can go in order. So we can start off with the raw staging layer. Yep, so we can open up. So essentially this is a sample script of the raw staging layer that gets the Automate DB will start actually run. So here, all this is doing is just selecting certain columns from the relational table. In this case, the address table. And I see a really good question in the chat. Find what HS and LS is. So through this kind of process, we want to keep a standardized process in order. So it's essentially, the process is that anything with an LS stands for link satellite, HS is a hub satellite, H underscore is a hub, L underscore is a link, and then I believe yep, that covers the four main entities that we use. You can essentially append anything to that. We use those particular prefixes because we found it to be easiest. As long as we're maintaining some sort of consistency with how we name every hub, every hub satellite, and every link, it doesn't really matter. So back to the Python script. Once we create the raw staging layer, we go into the hash staging layer. So we're going to open sample hash staging layer first. So same thing with the HSL address. This is just a sample script again, using the intelligence from the stored procedures that we had in the SQL Server Management Studio. We're able to essentially auto-generate these scripts for every single table. So essentially, whether we have, like Srini said, five tables, 500 tables, or 1,000 tables, it all just always auto-generated and follows the exact same patterns and exact same procedure. So in this case, we have that HK address, which is the hash key that goes that's going to be stored in the hub. The HDHS, which is the hash diff that gets stored in the satellite, and then the payload, which are the columns. So after this, we can go directly into the raw vault where we have the hubs, and we can see that all the hubs are prefixed with H underscore, all the links are prefixed with L underscore, and again, all the satellites are HS underscore, and the link satellites are prefixed with an LS. So as long as that naming convention is consistent, regardless of what prefix you use, this generation is still going to work. So in this case, if we take, for example, that link satellite, these are automate DB macros. So essentially at the beginning, the lines 3 to 8, we can see that we're setting some global variables that we could then pass into that automate DB.satellite, which essentially creates that satellite for us through automate DB. So right here, we're essentially just automating the actual Jinja script. So automate DB follows the Jinja scripting language. So essentially just auto-generating that Jinja script through Python, which we can then pass into DBT for DBT to actually push the data and create those payloads, that actual data vault model in Snowflake for us. So Srini, do you want to go into the DBT auto generation now?
So once actually the scripts are auto-generated using the Python, what we're doing is we are actually running the DBT script. So you can see my Visual Studio, correct? So what we're doing is you're just saying DBT run. So in this particular case now, what it is doing is it is actually taking all the auto-generated the scripts, and then it is actually pushing it. It is actually constructing the model in the Snowflake. The only thing that we did manually in this case is the actual creation of the actual project, which one is actually a table, which one is actually a view, is all we're actually specifying here at the layer level. And barring that, the rest of it, including the schema.yaml, is auto-generated. The interesting part of this, which we'll be briefly touching, is the test cases are also auto-generated. And then we'll actually talk about some of the customizations we did, and we created these test scripts by using the same concepts of DBT macros, and we are leveraging that to validate that the model that we generated is actually has no challenges. Okay, so with that now, while this takes actually around 1 minute to run, while that is running, so now let me switch my screen. My intention today is to just show you the high-level concept, and obviously everything has a lot of detail associated with it, so you get the flavor of how this is so practical and what is our approach. You can see my PowerPoint, right?
Yes.
So in here, again, these are some of the slides that we already talked about. And so these are some of the tables in the database that has information about the lineage. And some of the tables are actually created to generate the test cases. And very high level, this is the line of construction. From the source, which is actually in our on-prem relational databases, we are leveraging actually a CDC tool. The CDC tool that we leveraged in our case is HVR, which is part of Fivetran right now, to produce the replica on Snowflake. And once I have that replica, this is my source now. From this point onwards, the whole Automate DB is actually used to auto-generate the raw vault, hash stage layer, raw vault, and business vault. And in this particular case, we also have embedded concepts of making sure that there is no data loss. From the data loss perspective, number one, anytime there is a data movement, there is a potential chance of data loss. If I combine the data movement along with some business rules, it becomes extremely complicated for me to prove that there is no data loss. But rather, in the concepts that we apply here are, do not combine the data movement with data transformation. Therefore, it's easy for me to auto-generate the validity of the data between source and target. So in this particular case, the data is actually moved from the source to the target. All I need to do is auto-generate some of the hash keys of all records and then do a run between those two. And if they are same, they're same, right? The same concept here. Because this is actually a table, and all I do is compare again by using a hash case. So those are the test cases that you see right now. In this particular case, now you're actually doing a transformation. You're creating the hash keys. At the time, no data movement. So therefore, we created views. Of course, actually, a view can also be changed to a table if you are concerned about performance. At that time, again, I apply the same principle of, can I compare these by using the hash keys? But in that case, I need to be excluding some of the transformation that happened to construct the hash keys. And then we created the raw vault, which is actually taking the concepts from here, and then there are also views. And from here, again, you are creating views into the business vault. So therefore, in this area, I don't need to worry about the data transformation. The only thing that I need to, data loss. Rather, what I need to be confirming about is whether the transformations that I'm applying here are giving me the same output that I'm predicting. Such as, okay, the keys needs to be present in the hub, before they're present in the satellite, etc. So those are the test cases that we rely on to prove that there is no data loss and the output generated is trustworthy. And this is a little bit of an explanation about each of the layers. In the replica, we have extra columns like sequence number and sequence date, which is actually part of the product itself. And then it also contains DML operations like IUD. The raw staging layer actually contains extra columns like carrier name for multi-tenancy and SOR type, which is to represent the source name. In our case, we have database names like CLTCAS, LTCAS, or stuff like that. So we just mentioned that, okay, it tells you where that came from. These two concepts are actually used. This one is carrier name is used primarily for multi-tenancy purpose, and SOR type is used for master data management, where the data is coming from multiple sources, and you're actually combining that. In the hashed columns, you have an extra column called load date, so you know when it is loaded. And then the standard vaults, and then the business vault. And from this point onwards, on the exit side of it, you have the concepts of what you are, whatever additional business logic you want to create for the purposes of consumption. I think we talked about that. And then when you run this DBT, initially, I think we're kind of running a little bit short on time. So I'll just run this through, and then we can get into the details and then any questions associated. So in this particular case, initially, when I run the DBT, I expect only the 450 records as an example from the address. The raw vault, hash vault, contains 0 records, right? And then when you run the DBT, which you saw me running, it actually populates the data into all of these layers. And then you just add one extra record to the source data to mimic the CDC concept. And then when you run the DBT, that record is actually migrated to all the vaults. So you update a record, And this is where you start seeing that the automate DB power of populating the hubs and satellites the right way. Meaning, in this case, when you update a record, it's a history. So therefore, we expect only the satellite to increase and not the hub. You see that the hub actually have only 451 records, and whereas the satellite has 452. So this is where we start actually, start seeing some of the value of the additional value of automate DB framework. If you can just repeat the same thing, you're updating the same record one more time, and you continue to see that the hub has only 451 and the vault has 453 records. And in this particular case, I'll just run, the tests as well. So Sriram, while the tests are running, do you want to just briefly talk about some of the test framework, which we selected from Patrick Cuba, the book called Data Vault Guru?
Sure. So, like Srini pointed out, a lot of the data vault concepts and relational concepts are based off of solid set theory. So leveraging that, we can essentially streamline the testing process and essentially kind of ease that process for us. So instead of checking every single record, we're looking at the entire set as a whole. So essentially going back to the HSL test, so essentially checking if the keys in the raw staging layer match those in the hash staging. So essentially in this situation, we're taking all the keys in the hash staging layer, subtracting them from the raw staging layer, unioning that with, again, the reverse operator where we're subtracting the HSL from the RSL. And if that set is null, then that means that we know that all the keys in the raw staging layer did get mapped to the hash staging layer. Similarly, we run tests for each of the artifacts in the data vault. For example, the hub test. In the hubs, we have to check that all the primary keys are not null. And the implementation wise, that's just a mathematical way to write out that particular test. And the second is making sure that every single hub key is unique. So in this case, again, we're just making sure that all the keys, there's no duplicate keys in that particular hub. Can you go to the next slide? Yep. And like Srini pointed out, also these tests are taken from Patrick Cuba's Data Vault Guru book. So we reference that throughout this process. So for the links, similarly, we're checking that that no link key is null. We're also making sure that all the link keys are unique. And then finally, the unique test here for links is the orphan check. So making sure that all the keys in the links are present in adjacent hubs. So because links are essentially connecting one or more hubs together, we need to make sure that all the keys in those hubs, in those adjacent hubs that the link is connecting, are actually present in that link and in those adjacent hubs. So the test for this is making sure that the L minus H, which are the keys in the link minus the keys in the hubs, gives us a null set. Similarly, the satellite test, we run the null check, we run a unique check, and also the orphan check. So making sure that all the keys in the link satellite are present in the adjacent hub. And this isn't transitive, meaning that H minus LS doesn't necessarily give us a null set, because all the keys in the link satellite should be in the hub, but not vice versa.
Okay. So now I'm actually, when I run all the test cases, let me share now my Visual Studio. Behind the scenes, I just ran the tests, which is simply, DBT test. It actually takes all the test cases that are in the schema.yaml and then runs it. It actually ran all the test cases, and it actually, mentioned that there is actually one failure. And then we can actually inspect those failures and find out why there is actually a failure, right? So there is actually a nice product called EDR that actually produces a nice report showing me the list of error messages as well as the success, which is part of the elementary product package. It's also an open source, and also tells me the actual query that actually failed. So while this is actually coming up, let me briefly show you on the Snowflake. Okay, so this is now the Snowflake screen. Let me just briefly refresh this. the vault, when we actually ran those DBT scripts, it actually automatically produced the business vault. The elementary is the test framework that it automatically creates as part of the when you say EDR run. The hash staging layer in information schema is just specific to Snowflake, where you're actually keeping track of the model. And the raw staging layer, the raw vault, which also has these hubs, links, and satellites. So all of these tables, the data, along with including the business vault, all of that is auto-produced. And you can simply query some of these tables if you want. That actually tells you a little more details about the data that you are talking about. Now, speaking of the failure, while that is running, I'll just show you the what it produced, and then we can go back and then see. It will actually, what it is saying is that there is actually a record in the product in the product hierarchy table, that in the link satellite in the link table, whose key is not actually present in the hub. In this particular case, essentially this is the test that is actually failing. What we expect is always all the keys that are present in the link are expected to be found in the hub, not the hubs. But there is an exception here. Why is that? When we actually look into the SQL database, what we observed is that this is actually a hierarchy table. In the case of a hierarchy table, the root nodes don't have a parent. This is exactly the case here. In this case, the root nodes, which are actually part of the product parent product category ID, is going to be null for those whose product category ID is root node. Because this is a null key, it is going to be present in the link as a null, which is kind of calculated field, right? So again, these are all either hidden behind the automated DB, which knows how to actually handle some of the null keys and then manage this. But when you actually run the test cases, you understand why there is a difference. In this case, this is a false positive, where you are saying that there is a key that has no parents, and therefore the records that are associated with that are coming as actually a test failure. And when you actually look into the actual data associated with them, and you see that there are actually 4 records for which the parent is actually missing in the table. Let me. Okay, so let me show you in the SQL Management Studio.
Just remind you to keep an eye on the time. We're coming up to the end.
Yeah. So the folks, I think that is. Maybe I can just show you the last concept here, which is just the EDR report, and then we can actually open this for conversation. So I just mentioned about this elementary report. It actually nicely produces actually a report like this, which actually clearly shows that here is an error message. And when you click on that error message, it actually tells you the query that actually failed. You can directly run this query in the Snowflake, and that tells you, specifically the records that I just showed you about. With that, I think I just want to, in summary, what we want to say here is that, we actually followed more like a practical approach than being religious about what is exactly the data vault. In this particular case, our clear goals of really are, separating the payload from the keys so that any further changes to the model are limited, have limited ripple effect on the relationships. And therefore, my business vault and the subsequent models are more stable. I can auto-generate some of the joins because we have clearly we know the keys between the hubs and links, and the join is always based on hash key. Therefore, it can be auto-generated. See that it's actually giving you a nice pattern to avoid, hand holding all the joins, right? But if you are actually talking about any filtering of the data, or you're talking about, more complex queries based on which tables to pick for what purpose, and that's where you end up actually, writing manually. Of course, some of that now with the new AI-based approaches, it can detect the table names based on the description that you specify and then auto-generate some of that as well. So now you're also creating a path towards auto-generation of the queries in the future.
Great, thank you very much.